Welcome to talk about an AI-driven penetration testing CLI tool that speaks in plain language and hunts for vulnerabilities. It's called VulnClaw, a standalone agent that combines large language models, a modular tool chain, and a library of penetration testing skills. You can tell it, penetrate httpexample.com, and it will automatically walk through reconnaissance, vulnerability discovery, exploitation, and report generation. The tool relies on several foundational pieces: an LLM agent that can call tools and follow natural language instructions, the model-coded programming interface, a tiny set of services that let the agent control tools like HTTP requests, network scanners, browser automation, and more, a skill orchestration system that bundles discrete tasks such as port scanning, web fingerprinting, CVE checks, and POC execution. It works with many LLM providers that support the OpenAI API shape, such as OpenAI, Minimax, DeepSeek, and several others. You simply configure the provider, supply an API key, and the agent kicks off. What it can do. The core workflow is described by a simple script. When you give the agent a natural language command, it starts looping over 4 rounds. Round 1, reconnaissance, identifying fingerprints, scanning ports, enumerating directories. Round 2, vulnerability discovery, hunting for injection points, known CVEs, and configuration weaknesses. Round 3, exploitation, running proofs of concept, gaining privileges. Round 4, report, producing a structured markdown report and a Python POC script. The agent can be used for authorized penetration testing, CDF competitions, routine rehearsals, or security instruction. It automatically stops when the goal is reached or the search space is exhausted, thanks to target-driven engine. Highlights, period. Feature, description. Target-driven engine moves out of fixed round loops, stops when the objective is achieved, the search frontier is exhausted, or a safety budget is hit. Blackboard graph models the problem as moving from an origin to goal using 2 concepts, fact and intent. Facts are confirmed truths, intents are suggested next steps. Anti-hallucination gates. Every claim must appear character bit reactor and real tool output to be trusted. Natural language interface. You talk, and the agent figures out the phases and tools. 13 LLM providers. Choose freely from OpenAI, Minimax, DeepSeek, Zippo, Moonshot, Qwen, Silicon Flow, Dongbao, Beichuan, Stephan, SenseVision, Yi, or a custom provider. MCP tool chain. 4 services: fetch, memory, Chromedev tools, and BERT provide HTTP requests, context persistence, browser automation, and proxy capture. AI Agent Core uses tool calling and autonomous looping, structured reasoning and adaptive reflection, keeps facts, constraints, and attack chains, auto-classifies failures and escalates payloads from L0 to L4. Vulnerability plugin system. Localplane plugins plus read-only web plugins that feed findings into the session. 21 skills, 7 core and 14 specialized skills covering web, Android, client reverse, cryptography, OSINT, and more, with detailed reference docs. 29 encoding decoding operations, automatic base 64, hex, URL, AES, JWT, and others. Python code execution. Python execute lets the agent build payloads, but its hierarchy cannot isolated. Persistent testing runs for many cycles, generating a report each cycle until stopped or a limit is reached. Display control. Toggle the internal reasoning process with a simple command. Sandbox prompts enables the agent to conduct software testing in authorized scenarios. Web UI launches a local web server, allowing the entire flow to be controlled through a browser. Architecture overview. Imagine a diagram. At the top, the CLI or TUI serves as the natural language layer. Beneath sits the LLM agent, which orchestrates tasks. Another layer handles MCP services, feeding tool calls back into the agent. Finally, a knowledge base offers references and constraints. The core agent wires all these parts together, and plugins can be added at runtime for new vulnerability checks. Running the tool. You can get started by installing from pip install VulnClaw, or clone the repo and install in editable mode. For Docker, a pre-built image contains the web UI and MCP services. Just run docker compose up, build, or invoke a single CLI command with an environment variable for the LLM key. At a minimum, you must set the provider, e.g., VulnClaw config provider Minimax, the API key, e.g., VulnClaw config set LLM API key or key. Once configured, a simple command launches the interactive CLI. VulnClaw. Give it a target. VulnClaw target 192.168.1.100, or run a full scan. VulnClaw or run 192.168.1.100. For long-running sessions, use the persistent mode. VulnClaw persistent 192.168.1.100. You can also use the TUI or the Web UI for a graphical interface. Commands overview. The CLI provides an extensive help listing. Some key commands. Run, initiate full lifecycle using the new target-driven engine. Persistent, loop over many cycles. Recon, scan, exploit, individual phases. Report, generate a report from a session file. Solve, invoke the target-driven solver directly. Config, manage settings, providers, and API keys. TUI, launch the terminal UI. Web, launch the browser UI. Plugins, list, run, and inspect vulnerability plugins. Example usage. VulnClaw config set LLM base URL https://api.apane.com/v1 VulnClaw solve example.com. Goal get flag, example reconnaissance session. When you ask the agent to apply a target, you'll see a flow like this. The agent says target 192.168.1.100. It lists open ports 22, 80, 443, 8080. It identifies the web server fingerprint, perhaps Apache February 4, 1962. It finds potential directories or applications, such as Tomcat Manager. It flags known CVEs and validates them through HTTP requests. After exploitation, it generates a markdown report and a POC Python script, saving them to .reports and .pocs. Configuration. The tool is highly configurable via a YAML file or environment variables. Key options include provider and API key engine type, solve, target-driven, or rounds, fixed rounds, stop conditions, maximum rounds, stale round threshold, persistence cycles, reasoning state and reflection toggles, plugin runtime activation and limits, paths for output and reports. Simply edit the file at .vulnclaw config.yaml or set the appropriate environment variables. Safety precautions. VulnClaw is intended solely for authorized security testing. Before using it, 1. Obtain explicit permission from the target owner. 2. Confirm the scope in writing. 3. Adhere to local laws and regulations. Unauthorized testing is illegal. The authors are not responsible for misuse. Contributors and community. The project welcomes contributions. Join the discussion on QQ groups or follow the repository on GitHub. Many developers and researchers share their insights and improvements. Closing. VulnClaw combines an LLM, a simple but powerful tool interface, and a library of penetration testing skills. It lets you ask, "Find me the flag on target.com," and it will walk you through discovery, exploitation, and reporting, all autonomously. Whether you're a team operator, a CDF participant, or a security educator, this tool brings the automation of AI into practical, hands-on testing. Thank you for listening.